Bradley. Okay, so what we did was we added and subtracted 1/2 of the x term squared. 1/2 of the x term. The x term is 4. 1/2 of 4 is 2. 2 squared is 4. Okay. I'm going to have to get rid of my extra. This isn't a trinomial. In case you haven't noticed, this has 4 terms, so we can't factor it. So what I'm going to do is I am going to distribute the 2 first to these 3 things and then to the -4. 2 times -4 would be -8. And this usually gives, out of all the steps, this seems to give people the most trouble, conceptually, because you've always distributed through everything. And this really isn't anything different. So think of it this way. If all of you were in this room, just like all those terms are in the parentheses, and I stood outside the door and I said, okay, well, as you leave, I'm going to give you a candy bar. If Sarah got called out for early dismissal and she left, I would give her the candy bar and I would tell all y'all, just wait till the bell rings, and then I'll give it to you as you come out. So this is what's going on here. We want the -4 to leave early, but everything in those parentheses has to get a 2. That's the way this distributive property works. So the -4 is going to leave early, so it's going to go ahead and get its 2, become -8, and everything else we're saying just wait here until later. So are we okay with that? I'll take that as a yes. So that's when I say the subtracted term leaves early, that's what I mean. So all we have left is to clean it up. This is a perfect square trinomial because the last term is squared and the square root is half of the middle. So that means it will factor into square of the first, square of the second, square root, I mean. Square root of the first, square root of the second, all squared. -8 plus 7 is -1. Factor and clean it up. So what we've done is taken a general form quadratic and we put it in standard form, which allows us to read the vertex and axis right out of the formula. So we could sketch it. This is something squared. That means it looks like x squared, except it has been moved to the left 2 and down 1. And it's positive, so but it's been steepened by multiplying by 2. So it's going to open up and it's going to be steeper than x squared. And we have a vertex at -2, -1, and we have an axis at x equals -2. It's not that bad, is it, Sarah? I mean, really, is it? I don't think it's that bad. We'll do another one then, just to be sure. Without the aid of a calculator, sketch and identify axis and vertex. And it is given to you in general form. We're just doing it together. Yeah. So yes. No, not yet. We'll wait a day before we do that. Okay. In order to do this, it has to go to standard form. It has to be a binomial squared plus something in order for us to do this without a calculator. So, what was first? We grouped the x's and something. Whatever's with the x squared. So if there is no coefficient, there's no factoring. But if there is, like there's a negative sign here, it's got to come out. So negative, that makes that a positive, that makes that a minus. It's starting to look like standard form already. So now the tricky part. You're going to add and subtract half of the x term squared, which is what? Yeah, half of the x term is 3. 3 squared is 9, so I'm going to add and subtract. The minus 9 leaves early. Negative times negative 9 is going to be a plus 9. And all that's left is the factor. So let's see, we have a minus, square root of the first, square root of the second, sign of the middle, squared plus 1. So the vertex is at 3, 1. Axis is at x equals 3. So sketch. This thing looks like an x squared, but it's been moved to the right 3 and up 1. 1, 2, 3, up 1. There she is. It's negative, so it's been flipped. It's terrible, but it'll do. The axis is at x equals 3. It's not so bad, is it, Courtney? I mean, really. Erica, it's not so bad, right? If you go slow, do it one little step at a time. Do you think it's bad, Kim Kuhn? Okay. Instead of Andrew, there's just a red backpack in his place. It really isn't much different. He would be doing the same thing if he were there. He'd have the same. Oh, that was too funny. I was thinking that, but it didn't come. It just didn't come out quite as elegantly as that. On a certain page. Oh, there it is. It's 214. We are able to do amazing things now. We can find the vertex and the axis of anything. And if we have a picture, we can come up with the equation from that if we know the vertex. Right, Amelia? Oh, Amelia. Oh. This procedure, Amelia, this procedure right here is called completing the square, or squarius completus. Where'd you go? Where were we? Good luck with that, Sarah. Where is she? I'm so distraught. All right, I'm going to put Amelia's little picture in here sometime. What's going on, Shannon? I made it.